We're given that z is 3 minus 4i, and we're asked to find the magnitude and the argument, well, and then the complex conjugate. So one thing you could do is just like learn or derive kind of the general definition for this. If we have z equals a plus bi, then this is the real axis, this is the imaginary axis. I'm going along a and up b. And then the magnitude would just be a squared plus b squared square rooted. And that's true even when things are negative, you still get that as your length. So we can just say it's 3 squared plus minus 4 squared square rooted. This is just going to be 5. Then for the argument, well, tan of the argument of z is going to be the opposite over the adjacent. And this still works. So it's the real part divided by, sorry, the imaginary part divided by the real part. This still works in when you get negatives. So we're going to get inverse tan of minus 4 over 3. You can use our calculator for that. We'll always work in radians. It gives minus 0.9272. Or to three significant figures, minus 0.927. So here I'm using the fact that you can have, yeah, you can define the argument to be 0 to 2 pi. That's one option. Or you could do 0 to pi and then 0 to minus pi. Another way to do this question straight from a diagram, though, I haven't actually drawn the complex number. So if I want to draw 3 minus 4i, it would actually be down here. So I'm going 3 in the positive. I'm just going to say the length is 4 here. And now I'm going to work out this angle. This would be inverse tan of 4 over 3. And that would actually give me positive 0.29272. Then I just have to realize to make it negative. So you've got two options. You can either use essentially this, like this is always true, or inverse tan of b over a, or we can draw a diagram and kind of figure it out from there that we're going to get the minus 0.927. Finally, for the complex conjugate, this is when you just swap the signs on the imaginary part. So I'm going to get 3 plus 4i. An Argand diagram, the complex number w is represented by the point A, and w star is represented by the point B. Describe the geometrical relationship between the points A and B. Well, we hinted at that on the last question. If I wanted a complex conjugate, then I'm reflecting it essentially in the real axis, because the imaginary part goes from down here to up here. That's how I got my 3 plus 4i. So that is the answer. Reflect. They are reflections of each other in the real axis. So I think 1 mark for reflections and then 1 mark for say on the real axis.